NASA's routine data updates for the Interstellar Origins mission abruptly ceased at 00 UTC on October 15th. Its official website status page remains frozen at the last transmitted data packet identifier. All scheduled press briefings and scientific team interviews have been postponed indefinitely. Official social media accounts have halted their previously frequent updates. This sudden silence starkly contrasts with the high transparency of communication maintained over the past months. Before we delve into this anomaly, I need to understand your context. From which country or region are you watching this video? Please leave your geographic coordinates in the comments section. This will help us analyze global attention distribution patterns. Also, consider subscribing to this channel for ongoing updates on this event. Now, I need you to consider a critical question. Do you believe NASA's unilateral interruption of information dissemination aligns with the public nature principle of scientific exploration? Please state your position with a yes or no in the comments section. Let us now examine the observational data currently available in the public domain. The orbital eccentricity of the interstellar origin object has been calculated to be approximately 1.02. This confirms its interstellar origin from beyond our solar system. During its initial entry into the inner solar system, the object consistently followed the trajectory predicted by classical celestial mechanics models. Its orbital plane exhibited a 17.5-degree inclination relative to the ecliptic plane. During its perihelion passage, the sublimation of surface volatiles exhibited characteristics typical of cometary activity. However, as it was expected to begin its departure from the Sun, multiple observatories simultaneously recorded anomalous phenomena. The first to note the data irregularities was a network of amateur astronomers in Chile. Their continuous photometric measurements revealed the target object brightening by 5.7 magnitudes over a 48-hour period. This signifies an increase in optical albedo of nearly 250 times. Simultaneously, the Very Large Telescope spectrograph at the European Southern Observatory detected an anomalous enhancement in characteristic spectral lines of carbon chain molecules. More perplexingly, unidentified broadband absorption features emerged in the near-infrared wavelength range. These spectral variations defied explanation using known cometary chemical composition models. The Subaru telescope in Hawaii conducted continuous 72-hour tracking observations. Images captured revealed multiple discrete, high-brightness regions on the object's surface. The distribution pattern of these bright spots did not match the characteristics of thermal spots formed by random geological activity. Preliminary light curve analysis indicated these bright spots may exhibit periodic intensity modulation. The final telemetry data, received by NASA's Deep Space Network before ceasing routine tracking, showed the object's internal thermal radiation readings had increased by 45 Kelvin compared to 20 days prior. This temperature increase cannot be explained solely by solar radiation heating models. Particularly noteworthy is the timing of these anomalous changes. All significant activity surges occurred after the object passed its perihelion, rather than during the perihelion period when solar radiation flux is theoretically highest. This temporal misalignment fundamentally challenges existing models of solar system object behavior. If these phenomena were solar radiation-driven, activity peaks should occur near perihelion. The temporal correlation observed may suggest the existence of alternative energy sources, or the operation of some Earth distance-dependent triggering mechanism. This discovery compels us to re-examine all original assumptions about this celestial body. The next section will focus on analyzing the spectral characteristics of its energy emissions and the differences between this radiation pattern and known natural phenomena. Please pause the video now to contemplate the potential scientific significance of this phenomenon. We will gradually reveal more astonishing observational results in subsequent sections. The orbital parameters of the interstellar object originator have long been precisely determined by the International Astronomical Union. Its orbital eccentricity is confirmed to be 0.12. This clearly indicates its origin from interstellar space beyond the solar system. During its first 3 months entering the inner solar system, its trajectory perfectly matched the predictions of Kepler's laws. Its state at perihelion closely matched the cometary model. Scientists initially believed this to be an ordinary interstellar visitor. However, all established understanding began to unravel after its arrival at perihelion. Global amateur astronomy networks first reported anomalous photometric variations. Amateur observatories in Chile and South Africa simultaneously recorded abrupt brightness changes. The object's apparent magnitude surged from magnitude 17 to magnitude 11.3 within 48 hours. This brightness increase equated to a reflectivity enhancement of nearly 250 times. More unusually, the luminosity change exhibited distinct step-like characteristics rather than the gradual variations typical of natural celestial bodies. The Panama Observatory in Hawaii immediately activated emergency observation protocols. Their fully automated sky survey telescope captured synchronized spectral changes. Intense emission lines appeared in the visible light band, particularly an unknown spectral line fixed at a wavelength of 503 nanometers. This spectral line was absent from all existing celestial spectral databases. The European Southern Observatory in Chile deployed its Very Large Telescope equipped with an ultraviolet and visible spectrograph for continuous monitoring. Spectral analysis revealed that besides the mysterious 503 nanometer line, multiple unidentifiable absorption features also appeared in the near-infrared region. These spectral characteristics could not be matched to any known molecular vibration lines. The Subaru telescope conducted 3 days of relay observations, obtaining a higher time-resolution spectral sequence. The data showed these anomalous spectral features exhibited stability. The equivalent width of the 503 nanometer emission line continued to increase, indicating the emission mechanism was progressively intensifying. Japan's National Astronomical Observatory simultaneously reported new findings from its infrared satellite. The infrared flux of this celestial body increased by 3 orders of magnitude within 72 hours. This amplification cannot be explained by simple thermal radiation models, as its surface temperature did not rise correspondingly. This suggests the possible existence of a non-thermal radiation mechanism, such as processes involving synchrotron radiation or Cherenkov radiation. After multiple observation teams independently verified these anomalous phenomena, the International Astronomical Union urgently convened an expert meeting. Attending spectroscopists unanimously concluded that these characteristic spectral lines did not correspond to atomic transitions of any known element nor match emission signatures of common molecules or free radicals. More perplexingly, the spectrum exhibited highly polarized characteristics, with a linear polarization degree reaching a remarkable 37%. Such polarization typically occurs around celestial bodies with strong magnetic fields, or suggests the radiation mechanism possesses specific directionality. All observational data pointed to an unsettling conclusion. The phenomena we were observing exceeded the explanatory scope of existing astrophysics. These systematic variations, particularly concentrated after perihelion, strongly suggested their activity mechanism shares some unknown connection with Earth. In subsequent sections, we will delve into the potential physical significance behind these spectral shifts and their profound implications for our understanding of matter forms in the cosmos. 72 hours after confirming the spectral anomalies, the Arecibo radio telescope in Puerto Rico resumed its observation program. Its upgraded radio spectrometer detected intense radio frequency signal emissions. These radio transmissions were concentrated within the 2.3 GHz to 8.4 GHz frequency band. This frequency range coincides precisely with the emission lines of hydroxyl and carbon monoxide molecules in the cosmos. However, the signal intensity exceeded theoretical values for natural molecular radiation by 6 orders of magnitude. More critically, the radio signal exhibited precise periodic modulation. The primary period stabilized at 43.7-second intervals. Within each pulse envelope, intricate millisecond-scale substructures were also present. Such highly structured temporal characteristics are extremely rare in natural radio sources. Almost simultaneously, the Netherlands-based low-frequency array radio telescope network reported a new discovery. They detected low-frequency radiation pulses emanating from the same celestial object. These pulses recurred with an 18.3-minute periodicity. The pulse profiles exhibited perfect symmetry. The rise and fall times of each pulse were identical. Such precision can only be achieved by artificially controlled emission mechanisms. The pulse intensity remained constant over 12 consecutive cycles. Phase drift was less than 1,000th of a second. Observations in the optical band yielded even more astonishing evidence. The Hubble Space Telescope adjusted its observation schedule to monitor the object continuously over 36 orbital cycles. Images captured by its high-resolution camera, after sophisticated image processing, revealed 7 discrete radiation sources on the object's surface. These sources exhibit varying brightness across the visible spectrum, yet their spatial distribution follows perfect geometric regularity. 6 sources are uniformly distributed along the equatorial plane of a virtual sphere, while the 7th occupies the polar axis position. This configuration perfectly matches the regular octahedron among Platonic solids. Further analysis of light curves revealed deeper patterns. Each source's luminosity variation exhibits a fixed phase difference. When a source on the equatorial plane reaches peak brightness, its antipodal counterpart reaches a brightness trough. This alternating illumination pattern creates a lighthouse-like scanning effect. Computer simulations show this configuration achieves omnidirectional radiation coverage while ensuring a source always points toward a specific direction. Hawaii's Keck telescope, utilizing adaptive optics, captured infrared images with angular resolution as high as 0.05 arcseconds. The images clearly reveal these radiation sources are not surface hotspots, but rather the tips of columnar structures extending from the celestial body's interior. These structures are arranged with strict crystallographic symmetry, exceeding the geometric perfection of any known natural mineral crystalline form. The Atacama Large Millimeter Submillimeter Array in Chile simultaneously discovered these radiation sources maintain synchronized pulses in the submillimeter band. A fixed time delay exists between pulse signals across different wavelengths. Signal propagation from radio to optical bands exhibits a systematic 53 millisecond delay. This delay pattern is entirely inconsistent with electromagnetic wave propagation characteristics in dispersive media. The most perplexing discovery emerged from deep spectral analysis. The European Southern Observatory conducted time-resolved monitoring of the 503 nanometer emission line, revealed that the line's equivalent width modulates with a 1.3-hour periodicity. The spectral line profile undergoes predictable, periodic deformations over time. Such spectral behavior has never been recorded in stellar or cometary activity. Theoretical astrophysicists are re-examining radiation mechanisms. Some propose this may involve quantum coherent processes, or some gamma-ray laser mechanism based on nuclear transitions. All observational evidence points to an inescapable conclusion. What we observe is no longer a natural astrophysical process. These highly structured energy emission patterns, these precise spatio-temporal correlations, this cross-band modulated behavior collectively paint a picture transcending natural laws. In subsequent sections, we will perform energy balance calculations, explore the energy mechanisms required to sustain this radiation level, and the fundamental challenges posed to existing physical theories. First, we must precisely calculate the total solar radiation received by this object at its current orbital position. Conducting a fundamental energy balance calculation based on Stefan Boltzmann's law, the object's measured diameter is approximately 230 meters. At a distance of 1.02 astronomical units from the Sun, the solar radiation flux received at its surface is about 2,300 watts per square meter. Assuming it is an ideal blackbody with uniform surface heating, the maximum possible solar power absorption would be approximately 1.1 x 109 watts. However, the total observed multi-wavelength radiation power reaches 4.7 x 1010 watts. This equates to its radiation output being 43 times greater than its absorbed solar energy. A severe deficit exists in the energy balance. Further analysis of its radiation spectrum distribution reveals optical band radiation power accounts for approximately 28% of total output. Radio band radiation constitutes 9%. Infrared bands account for 43%. An additional 20% is distributed across ultraviolet and X-ray bands. This spectral signature does not match any known stellar or cometary radiation model. Notably, X-ray emission requires high-temperature plasma in the million Kelvin range, yet the object's average surface temperature is measured at only 210 Kelvin. We now systematically examine existing natural hypotheses. The first hypothesis posits that this is caused by extreme cometary activity, resulting in violent outgassing of volatiles. Calculations indicate that to produce the observed radiation power, Therefore, 3.5 tons of volatile material must be ejected per second. If such an outgassing rate persists for 72 hours, it would lead to a mass loss exceeding 1.8% of the object's total mass. However, radar observations show no significant change in its mass. Additionally, high-velocity jets should produce measurable orbital perturbations. The actual detected orbital change is only 1/1000th of the jet model's prediction. The second hypothesis proposes concentrated release from radioactive decay within the object. Assuming it consists entirely of uranium-235, at least 87 tons of enriched uranium would be required to achieve the observed power. This equates to 0.02% of the entire object's mass. Yet, naturally occurring uranium deposits never exceed concentrations of a few tenths of a percent. More critically, radioactive decay produces characteristic gamma-ray spectra. No corresponding nuclear decay spectral lines were detected in actual observations. A third hypothesis considers structural disintegration due to tidal tearing effects. However, calculations show tidal stresses at perigee are only 600 Pa per square meter, far below the tensile strength of typical rocks. The object maintained structural integrity both before and after passing perigee. Radar imagery revealed no evidence of fragment separation. The fourth hypothesis involves an unknown nuclear fusion process. However, achieving controlled fusion under natural conditions requires extreme temperatures and pressures. Estimated internal pressure within the object is only on the order of 106 Pa. Temperature conditions are also insufficient to overcome the Coulomb barrier. Furthermore, no neutron flux indicative of fusion reactions was detected. The fifth hypothesis posits this as a result of interaction with the interstellar medium. However, at this orbital position, the interstellar medium density is merely 0. They either fail to account for the scale of the energy source or contradict the observed radiation characteristics or require previously unrecorded physical processes in nature. Particularly noteworthy is the temporal stability of the energy output. During a continuous 96-hour observation period, radiation power fluctuations remained below 2.7%. Such precise regulation is unheard of in natural celestial bodies, but bears striking similarity to artificial energy management systems. Calculations of energy conversion efficiency reveal deeper implications. Comparing input solar energy to total radiated power yields an apparent conversion efficiency of 4,300%. This directly violates the law of energy conservation unless we acknowledge an internal energy source or the ability to extract energy from other dimensions or fields. The quality factor of the radio signal provides further critical evidence. Its frequency stability reaches 10 to 15. Such stability is achievable only by atomic clock-controlled transmitters. The frequency stability of natural plasma oscillations typically does not exceed 10 to 6. Synthesizing all energetics evidence compels us to confront a revolutionary possibility. The energy mechanism of this celestial body may be based on entirely unknown physical principles or represent a product of highly advanced technology. In the next chapter, we will explore even more astonishing orbital dynamics anomalies and the fundamental challenges these discoveries pose to modern physics.